Welcome back. In this demonstration, we will be connecting a piece of standard screened audio cable to a standard, mono, large jack audio plug. For this demonstration, it is necessary to introduce the solder sucker, which is a desoldering tool. When the plunger is pressed down, it locks into place against a strong spring. By pressing the release button, the plunger shoots back, and a suction is created which will remove molten solder. To begin, the plug should ideally be supported in a small, portable bench vise. The stranded wires should be twisted together, as demonstrated, and both inner core and outer screening should be tinned. Next, tin the center core lug as demonstrated. The plug can then be rotated in the vise and the second lug tinned. During the tinning process, the holes usually become blocked with solder. The solder should be reheated and the holes cleared using the solder sucker as demonstrated. Now the wire cores can be pushed through the appropriate lugs and bent back to make a mechanical connection. Each connection is then soldered as demonstrated. Allow the first join to set before soldering the second one. Once both joins have set, any excess wire should be trimmed off just above the soldered connection. Finally, before assembling the plug, you should visually inspect your work for any imperfections. A good connection should appear shiny and clean and should be slightly concave in shape. A convex or ball-shaped connection is a common fault caused either through poor wetting or tinning, due to the presence of dirt, or the connection may have been moved before it could set properly. Do not add more solder to the join. This will simply be hiding or covering an already poor connection. To rectify the fault, the solder should be removed and the connection remade. In the following example, we shall connect a multi-core cable to a multi-pin D-type connector. It should be noted that when using new cables and connectors, cleaning will probably not be required before you tin the surfaces. However, if any oxide or dirt is observed, it must be cleaned off before tinning. To begin, the connector should be supported and each pin should be heated from below and tinned as demonstrated. Each core of the cable is also tinned. Next, the first pin is reheated and the wire inserted into the hollow of the pin. The wire should be kept still for a second or two to allow setting before moving on to the next pin. Once all connections have been made, remember to inspect your work and correct any faults before assembling the connector. With this type of connector, because the pins are very close together, a careless solder splash or use of excessive solder might cause a solder bridge between two pins. If this condition is not rectified, it could cause severe damage to the equipment that it is to be connected to. When using round multi-pin connectors, it is advisable to begin your connections at the center pin and work outwards from there. This will provide easier access to the pins still to be connected. Slightly different techniques to those demonstrated may be required because of the large variety of connector types available. However, the following basics apply to all soldered connections. The soldering iron bit must be cleaned and tinned. Operating temperature of the bit must be correct. The surfaces to be joined must be cleaned and tinned. Make a mechanical connection where possible. The solder should be melted by the heated join, not the soldering iron. The solder must be allowed to set or solidify naturally and should not be disturbed before it has done so. If you adhere to these basics, you should, with practice, make many trouble-free connections. That brings us to the end of Program 1. Join us in Program 2, in which we shall demonstrate soldering techniques relevant to standard printed circuit boards.